Hi, this is Matt, and welcome to my shop. So I don't know how many of you know, this is really just a part-time thing for me, hobbyist stuff that I do on my own. Maybe eventually get to do it as a regular job. I'm kind of headed that way. But at the moment, I just do this in between my other work. So I just want to make that clear to start with. So the winter is really busy, and I know I haven't posted in a bit. I should, by the time this video comes out, I should have a few up that have to do with getting this machine put together. If you haven't seen them, please go back, take a look at those. They'll show the conversion process. This was originally a strictly three-phase machine that ran on high voltage industrial power. And I only have 220 power here, single phase. So I went through a whole process of getting this converter to run on that, and I'll leave the details to that in the other videos. But it was a bit of a process. It took me, the better part of the winter to get everything done and to the state where I want it. But we're pretty well there now, and I'm ready to start doing some real projects. And one of the things that I really got this machine for is to try and start looking at maybe doing some automotive stuff, doing the bigger work that I could not do on the little mini mill that I built. So one of the goals I had is to do replaning on heads or resurfacing of cylinder heads. So I've got a junk one here. This is not a salvageable unit. Actually what happened, it was a valve seat that dropped, and when it let go, it destroyed everything in the cylinder. So I'm just using this as a test unit. I want to try this out. I've never done a cylinder head like this. So right now I've started, I just got it set up on here. It's not dialed in yet, so I've got to dial it in and get everything square, and then we're going to try to plane this off. Now if you've noticed, I've got this vertical. This machine is both a vertical and a horizontal. It's really designed as a horizontal first, and the vertical is an accessory. This overarm is basically an accessory on the machine. The stock machine comes with just a solid overarm that holds the outer parts of the horizontal. If you're not familiar with horizontals, let me show you quick. You can run a regular facing mill in the horizontal spindle back here, but mostly what they use is for like slitting saws and things like that. So this would plug into that spindle back there, and on the end here a support bracket goes on, and this spindle will go through, or the arbor will go through that support bracket and support it. And you put your blades on here. You can also use it for gear cutters, for cutting gears. If you have an indexer, which I just got an indexer here recently. So that may be something in the future. I'm not there yet, but I think in the future I'm going to try some simple gear cutting. So that's what this machine is primarily meant for, but it also, this is an accessory or something that you get as an added feature with the machine. And this one's actually special even for that because it has a movable quill on it, which most of them that have the overarm that's powered like this didn't come with the spindle, the movable spindle on it. So this lets you also use it as a vertical mill as well. So in past videos, you've probably seen a little bit of that. Now we're going to try doing the head, so let's move on to that. Okay, so I just have this set up on here now, and when I first did this, I just did a quick run on here. It's roughed in, but I still got to fine tune it. Right now I believe it's leaning back a little this way, so I need to adjust that. I'm going to run another pass here so you can see that, and also so I get an idea how much I have to move it. And once I get it straight up and down, then I got to work on getting this way here so that it is parallel with the table. So I think what we're going to do is run along the bottom here, is where I can get a straight path to see that it's straight that way. I need to make sure I can get a clear path where I'm on the bare metal but not get in the grooves there. And I also need to zero this out, so I'm going to move the table in, go one turn around so I've got a preload, and stop on 0, which right now is right over here. And let's see how that looks. Okay, so I think I was wrong here. I thought it was leaning back towards me. It's actually leaning towards the machine right now. It's climbing as we go. Okay, so I'm going to try and readjust this, and I'm going to pause while I get some tools. We'll lean this back just a little bit. I'll have to loosen these clamps and adjust my stance here. Overshoot. I gotta go back towards the front of the machine now. so that looks pretty close there. Now we're going to do the parallel to the table. And I'm going to have to come back because it'll probably all shift again once I do that. Hopefully not too much, and I just have to fine tune it after. Okay, so this end definitely has to go back quite a bit. Okay, so I'm hoping you'll be able to see this. I think I finally got it dialed in. It was a lot of trouble. I really need some kind of fine adjustment, something I can lock into the slots of the table and use like thumb screws to adjust the left and right for parallelism to the table. Because every time I move one end, the other end shifts. And then you got your other axis as well, and you move one and everything else changes, so it's a lot of dancing around. So if I can use thumb screws to lock one end in, I think it will make it a lot better. So that's a future project, is to make a little rig to do that. But let's see if we can do this now. Okay, so it's -1 at the start. Okay, and that seems to have pulled within about a half a thou, so I'm going to pull that good. So I'm going to come back and we're going to run across here. See if I'm in the right track here. Okay, that should be good. Okay, let's see how this goes. So we're right on 0 now. A little bit of bumping around, we're +1 there. But I think the edges are a little off. Now it's going back to 0. So I think this is just variations in the surface. Now we're a little under. Basically 0 though. Much it stayed until it got to right by the very end there. It stayed between -1 and 0. So there's a little over a thou of variation on this, but the ends seem to be pretty much about even. I'm going to call it good enough at this point, and we'll take it off, and it should be flat when I'm done. You know, we'll be, I think, within a thou of original parallelism, which is what we're trying to do right now. So I'm going to leave this with this setup, and I'm going to put my facing mill in, and I think we'll be ready to start this. So I came up with a little complication here. This is the face mill that I was going to use. Took this back so you can see it. This is a little over 6 inches in diameter. I think it's actually closer to 7. This came with the mill. You know, I bought the mill used, so this was equipment that came with it. And I figured this would be in the horizontal, but apparently they must have been using this in the vertical part because there's not enough clearance here to clear this speed lock that they have on the front of this. Not a big deal. I can still use it, but I'm going to have to take this speed lock off and just use the drawbar. I'm not going to complain about that because I really didn't plan on using this anyways. I just I don't feel that secure using that as the primary means to hold any kind of end mill in there. I know it's supposed to be, that's what it's for, but I'd rather use a solid drawbar and really pull it back good anyways. So I think I'm just going to remove that and run it as just a conventional taper, same as I do on the vertical up here. And just use the drawbar to hold everything in. That'll take all this bulk off the front and let it face up, because what's happening is the parts of the face mill are hitting this lock-in collar before it bottoms out on the taper. Okay, so I'm taking a closer look here, and there's this Allen screw here, which I first assumed was just to keep this on so that you can not have it spin off, and you just lock it to the machine and you could unscrew it and then remove the whole front, which I think it still does that. But also I'm looking at the way this goes, and it screws down and bottoms on the inner part there. I don't know if you can see that, right in there. And apparently what that does is it locks it so it can't unspin. So this is a little more secure than I had realized. So what apparently you do here is you have it loose, you tighten the locking collar down, and then you turn this set screw all the way in from the front of the machine here, and it locks that collar so it can't unspin while you're using it. So it is pretty secure, but still I'm going to take it off so I can get this job done. So it looks like what they did here is they've got a threaded collar under here that's split in half and locks into a ring on this spindle. And as I get this open, I see there's also a retainer spring on here to help with assembly. So now I gotta pop that spring off first, relieve the tension, and then we can bring this threaded piece off. And the outer collar here just threads onto it. So you get two halves like that, and that spring just sits in that groove and it hooks together. So hopefully now that should all fit. I don't see any reason why it shouldn't. Make sure I get everything out of here. I've already cleaned this before, but just where I've had it taken that off, and I'll make sure I didn't knock anything in there. Oh, I gotta put my locking tabs on first. So the blocks here, they're like dogs that hold keep the face mill from spinning or whatever you have in there. They help hold that together. At least I thought it did. It may not actually, because I don't see a hook on here. Yeah, it keeps it from spinning on the collar back here. You've got a groove on the back that those threaded pieces, the split ones, lock into. But to keep the whole thing from spinning, they grab onto the outside of this. I probably could have taken it apart without removing these, but I wasn't quite sure of the construction when I started here. So I ended up removing them to start. But these are a pretty tight fit. I had to give them a little tap just to get them in there. Okay, so I should be ready now. There we go. So now it sets in all the way. So I got to tighten up the drawer bar and should be ready at that point. So here's the back of the machine. This is the drawer bar. You can turn that in. Leave that all the way back. I'll go until that stops. About there, and then we'll tighten that one down over it. So I'm going to snug this up with the tools off camera. So about 6 1/4 inches on the diameter. So I'm measuring here because I want to set my my RPM to what would be appropriate for this. Okay, so this is kind of a mechanical calculator. It tells you here for different materials and cutters your feet per minute cutting. That would be right at the tip of the cutter as it cuts through the metal. So for aluminum with a carbide tip, which is what this is, says 1,000 feet per minute. So here we're going to set this inner ring here. I'm going to set that for 1,000. And then the outer one, you've got two numbers here, if you can see that. You've got outer numbers here, and this is the RPM, and this is for the diameter of the cutter in inches. So we're going to take this, and we're going to go put that on 6, because it's roughly a 6-inch cutter. And that should now be at the appropriate speed for that, and it's saying 615 RPM. So I'm going to just get everything in gear here and start lining up, and then I'll come back. So now I'll bring it back this way, and I'm going to touch off, and I think we're about ready to start here. Sounds like it just touched right there. I'm zeroed out now, and I'm going to try taking about 10 thou off this and see what it looks like. Well, so far, I'm pretty happy with what I'm seeing. Going to need another pass, but this is cutting excellent. We can get some close-ups here. Now, like I said, this is a junk head. I don't expect to get all that out. But actually, this came out flat all the way across. I don't have any misses. A little bit of pockets there. I don't think it's a problem. I could do one more just to take that out. But really, this looks really good to me. It's a little smooth for automotive work, but I think it's okay. I think it's enough texture there. You just need enough to grip the your gasket so it doesn't get blown out. I think there's enough there, but it is a nice fine finish. Okay, I'm going to go another 10. And I think I'm going to call it a wrap on that. Okay, so it looks like that did it. Those little pock marks right down here are gone. And this looks excellent. I'm real happy with this. So that's our first base milling on doing a cylinder head. Thank you for watching. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.